Okay, we're doing 15B, question 5. So, um, starting to get a bit harder with unknowns in these equations. So, the tangent to y equals 2x cubed plus k 2x squared minus 3 at the point where x equals 2 has gradient 4, find k. Right? So we could find k not from this equation, but from the derivative, because at x equals 2, if we have a derivative, we could plug the 2 in, we know the answer would have to be 4, right? Because the derivative is the function, the gradient function. So let's go do this problem. All right, so we're in the section of the book where we're looking at tangents and normals. We're also doing calculus, right? So pretty much every question you're going to find a derivative at some point. Okay, there's my equation. The derivative, using our power rule, is easy to find. So that's 3 times 2 is 6. 3 minus 1 gives me 2. Right, k is just a number, so it'd be 2 times k, and x to the power of 1, and the derivative of minus 3 is 0, so we're done. We know that at x equals 2 on the curve, this function has to equal 4. So this equation, we could say at x equals 2, m equals 4, and I've already written that. So I might just say dy dx equals 4. And then I could say therefore, what do we get? 6x squared plus 2kx has to equal 4, right? At x equals 2. Oh, okay. I don't need to leave those as x's. The x's equal 2. So let's sub those in. Equals 4. So now it's just algebra, right? 6 times 2 squared is 24. 2k times 2 is 4k. Equals 4. So 4k equals 4 minus 24, which is minus 20. So k has to equal minus 5. And we've found k, which was part 1 of the question, I believe. Let's just check that. Find k. Find the equation. So I'm looking at b now. Find the equation of the tangent at the same point where x equals 2 and the gradient's 4. All right. The equation of the tangent. Right, so I'll bring everything back. So that was a. We can try and draw a line that's reasonably straight. It's not too bad. I'm going to look at b now. B. So we want the equation of the tangent. Remember, to get a tangent, we need a point and we need a gradient. We've already got a gradient. It's 4. They told us that before we started. If I was to plug x equals 2 into this derivative, see, I can rewrite this derivative now because I know what k is. So I could say, let me just get a small eraser. I could actually say that that is, if k is minus 5 and it was minus 2k, this would be minus 10. Right, so that would be my new derivative. And if I plug x equals 2 into that, then I will get the answer of 4, right? 6 times 4 is 24, minus 20 equals 4. But they've already told me, right? The point, though, they only told me the x value. So I need to work out what the y value is. I don't have the full point. All right, the y value is given by this equation, right? It's given by 2x cubed. Now I know what k is now, it's a minus 5. Minus 5x minus a 3. Okay, therefore this point is, let's work it out. So y at x equals 2 is 2 cubed minus 5 times 2 minus 3. So we get 8 times 2, 16 minus 10 minus 3. No, sorry, that's squared. So it's not minus 10, it's minus 20. Fix that up. And that will equal minus 7, I think. 16 minus 20 minus 4 minus another 3 minus 7. All right. So at x equals 2, the y was minus 7. Right. So I now have my point. It was minus 7. Okay. And I'm going to make a bit of room. Keep all this on the same bit. Whoop. That'll do. Okay. So this is the way I find the equation of the line. I just use the formula for gradient. So I say the change in y minus 7 over the change in x equals the gradient. All right. So we end up with y plus 7 would equal 4 times all of x minus 2. We can tidy up until we get a y equals mx plus c. Look, so we'd have y equals 4x minus 8, 4x, and then we'd have to minus 7. So the book will write it in this form, and there's our equation of our tangent. Now they also want the equation of the normal, I believe. So part C, so that was equation of tangent. This is now equation of normal, and the procedure's almost identical. The only thing is that the gradient of the normal will equal minus 1/4. So it is the negative reciprocal of the gradient on the curve, or the gradient of the tangent to the curve. Right? So we'll do exactly the same thing as I did here. We'll go y plus 7 on x minus 2 equals negative 1/4. Now because you're going to get a fractional value of x, the book likes whole numbers. So what I'll do to get the whole numbers, we'll do a little cross multiply. Just remember brackets are implied. So we could say 4y plus 7 equals minus x minus 2. Right, so times in both sides by 4, times in both sides by x minus 2. We'd have 4y plus 28 equals minus x plus 2. We could say x plus 4y equals minus 26, and that's how the book will write the equation of the normal in this instance. So this is what I would call a general form, I guess, for a straight line, and this is what I'd call the slope-intercept form. It doesn't, like I've been discussing in class, write it the way the book does, but technically, right from the start, when you set up your gradient expression, these are technically the equations that you need. They're just in a different form, so we're just doing some algebra to get it into the layout that the book uses. All right.